Now we're gonna talk about the region of convergence for the two-sided Z-transform. Remember, we are dealing with the infinite sequences. Whether it is left-sided Z-transform, right-sided Z-transform, or two-sided Z-transform. You can also call unilateral or bilateral Z-transform. These are the infinite sequences. We are dealing with the infinite sequences. So let's learn about the region of convergence for the two-sided Z-transform. Equation of the two-sided Z-transform is x of z equals to summation of x of n times z to the negative n, where n starts from negative infinity up to positive infinity. Let me show you the region of convergence in real and imaginary plane, which is the complex z-plane. Region of convergence for two-sided Z-transform is possible or exists if the right-sided radius is less than the left-sided radius. So we're gonna have such kind of shape, where the region of convergence will be the intersection of the right-sided radius and the left-sided radius. Look, we are dealing with the two-sided Z-transform. So what will be the region of convergence for the two-sided Z-transform? This is the mathematical equation, which starts from negative infinity up to positive infinity. This is a two-sided Z-transform equation. Now, when it comes to the region of convergence for two-sided Z-transform, we're gonna deal with both the left-sided Z-transform and the right-sided Z-transform. So this R sub R means the radius of the right-sided, and R sub L means the radius of the left-sided. So the region of convergence for the two-sided Z-transform is possible if the radius of the right-sided Z-transform is less than the radius of the left-sided Z-transform. This is the region of convergence for the left-sided Z-transform. If you remember, this was the region of convergence for the left-sided Z-transform, and its radius was R sub L, radius for the left-sided Z-transform. Similarly, when you look to this black region, this was the radius for the right-sided Z-transform. Remember, my R sub R was here. From here up to here, this was my R sub R, which was the radius for the right-sided Z-transform. So the radius for the left-sided Z-transform is greater because it starts from here up to here. So this radius is bigger than this radius. The radius of the left-sided Z-transform, which is my R sub L, is bigger than the radius for the right-sided Z-transform, which is my R sub R. So if such is the case, as we have it here, that the radius of the left-sided Z-transform is up to here. R sub L is here and R sub R is here, which is the radius of the right-sided Z-transform. Condition says that R sub R must be less than R sub L. Now, this combined region, this gray combined region will be the region of convergence for the two-sided Z-transform. Except this combined region, this region or this region, whatever place you take, is not the region of convergence. Region of convergence is only this combined part. Therefore, we can say that the region of convergence for the two-sided Z-transform is the intersection of the right-sided radius and left-sided radius. This is the intersection. Intersection means the combined part for the left-sided and for the right-sided. Suppose if my R sub R is this, is up to here, and my R sub L is here. So from here up to here, this combined region will be the region of convergence. The region of convergence for the right-sided Z-transform starts from here, onward towards the right side, This whole region will be the region of convergence. But the region of convergence for the left-sided starts from here towards the zero, coming inside. This will be the region of convergence for the left-sided. When it comes to the two-sided Z-transform, it is the addition of the left-sided Z-transform and the right-sided Z-transform. So we're gonna add their region of convergence. When you add their region of convergence together, the combined part, the common section, and the common region will be the region of convergence for this two-sided Z-transform. Other than the common region won't be the region of convergence. Only the common region, this ring shape will be the region of convergence. Now let me show you properly. This is This is going to be the region of convergence, which is the intersection of R sub R and L sub R. This ring shape will be the region of convergence for the two-sided Z-transform. If you look back, look, this ring shape, this gray ring shape starts from here up to here. This will be the region of convergence. I repeat it. The region of convergence for the two-sided Z-transform is always an annular shape or in a ring shape. This ring shape is only possible if the radius of the left-sided is greater than the radius of the right-sided. It won't happen if radius of the left-sided is less than the radius of the right-sided. You must check this condition, otherwise it is not possible to have such a ring shape. We have learned all the three types of region of convergence for infinite sequences. Region of convergence for the left-sided Z-transform, region of convergence for the right-sided Z-transform, and region of convergence for the two-sided Z-transform. We saw them graphically. So I hope you got the concept at this point. If there is still doubt, don't worry, we're gonna do the properties of the region of convergence. We have some properties of the region of convergence. We're gonna repeat all these things again, and you're gonna learn it much better than at this stage. So just stay tuned.